I feel the need for speed. That is one of my favorite quotes from one of my favorite movies, Top Gun. Welcome to SQL Server 2017, the Fast and the Furious. My name is Bob Ward. I work for Microsoft. Maybe you've heard of our company. I'm really here today to hope to convince you that what we've done in SQL Server 2017 and even in 16 is really great for performance. No matter what kind of application you're trying to run against our database system. So if you don't know me, I'm a principal architect for the Microsoft SQL engineering team. I used to work in the support organization. I am very, very, very proud to tell you that I just celebrated my 24th work anniversary at Microsoft last week. So thank you. And this is my 15th year presenting at PASS. I love coming to this conference. I'm honored that they would ask me to come present today. Hey, a couple logistics about what we're going to talk about. I'm very, very passionate about making sure you have the information I'm giving to you immediately. I'm really, really tardy about putting it on the PASS portal, which is okay because I know that they turn things into PDF files there, which is fine. But if you go to aka.ms/bobwardms, which I have on the slide here, and I'll put that on the last slide at the very end of the session, this deck and the demos I'm going to show you are all available. You can download them right now if you wanted to. So please, I encourage you to use that information, and then you might find some other interesting talks and presentations I've done in the past as well on that site. You might also take a look at aka.ms/bobsql. That's a blog post that my colleague Robert Dorr, also known as Bob Dorr, Bob Ward, Bob SQL. People get us confused. He's the smarter guy. We kind of do some interesting blog posts up there, and so I encourage you to look at that blog post as well for things about SQL Server. Let's get into what we're going to talk about in our session about performance, and you cannot talk about performance unless you've got numbers. And we've got some numbers that I think are significant. First of all, I'm going to show you in a demo here in a few minutes that pretty confident on this laptop right here, I can do 1 million transactions per minute on a laptop. For those of you that attended my Linux session yesterday, let's all just cross our fingers and do this and never, and hope that the fall Creators Update doesn't get pushed again. I did successfully apply it actually last night, so let's hope that all works out. 1.2 million batches per second, we can do that with things like our Hackathon technology, in-memory LTP, and then some of our benchmarks, which sometimes I think a lot of people just kind of gloss over these numbers, but we consider ourselves the price performance leader in benchmarking in OLTP and in analytic queries, TPC and H, and we kind of got the numbers to prove it. And what's really exciting for me is that these are numbers I'm showing you that we've done on SQL Server 2017, both on Linux and on Windows, but we even have some new numbers coming out even this week and in the next coming week. So look for a future blog post from me coming up about some new benchmarks that we're actually delivering on. And then how about 180 billion rows scanned in less than 20 seconds with 480 CPUs? My colleague Travis Wright demonstrated that live at Microsoft Ignite. Go back and look at Travis's Ignite video, SQL 2017 Deep Dive, and he live connected to a server we have in our labs where we did that kind of type record performance using Column Store. I don't have that live today, unfortunately, but I have some other fun stuff to show you near the end of the talk. And if you don't think Azure Virtual Machine doesn't have some capacity, it does. We'll talk about what those numbers mean. And then finally, that last comment about RAM and cores and so forth, I'll mention a little bit at the end of the slide, what do I mean by those numbers? So when I think about our performance and kind of a theme about what we offer, I kind of think of it this way. I think we're pretty fast, simple, built, and online. Like without a lot of changes, we're pretty darn good about giving you database engine performance. But you can go faster with the right type of changes, using the right features and the right tuning. And then if you really, really want to get fast, the fastest database on the planet, as Rohan said, I call it everywhere, cloud and planet, you can even do more configuration. But better yet, maybe you saw in the keynote a brief demo I did, which I'm going to go in more detail here in this session. We believe in keeping you fast and tuned, that once you get to the speeds you want, we can actually keep that performance up to the level that you expect. But first, let's talk a little bit about what I was here last year. I came last year at this session, at this conference, to talk about SQL Server 2016, It Just Runs Faster. And if you remember anything about that series of blogging that we did and the talks that I did at conferences like PASS, it was all about these themes. It was all about keeping pace with modern hardware, making things default run correctly, partitioning for speed, doing things larger in parallel, and making sure we eliminate this concept that I coined last year called reverse scalability, the concept where you would push your workload hard with harder hardware, with more hardware, more resources. And instead of getting scalability, it would actually get worse than it did before. That would be the worst thing you could see. And these are the kind of features that I talked about that we did. So I am here to talk about SQL 17, and all this functionality exists in it in 16, but 16 is still a great release that we have. So I want to make sure if you're in the audience today going, hey, you guys are so fast for me, I'm just deploying 16. I don't get this stuff in 17. 16 is still a great release, in my opinion, for performance. And you can go read the blog series that we produced well over a year ago talking about these features. If you're looking to do migration, both to 16 and 17, something you may not have seen before, we have a new migration guide. It's a pretty handy resource for you to go out there. I've got hyperlinks for you to look at in the decks later. If you're making that choice, a lot of people I've talked to recently are right now in that phase of thinking, I'm on 2008 R2, I'm thinking about making this change now, and I'd like to go to SQL 16 or 17. We've got some great resources for you to take a look at if you're making those decisions. Well, what about SQL 17? You know, I did this 16 series on It Just Runs Faster, and if you look back at that list, some of those things were kind of like behind the scenes, like things that were not showing up in a brochure that we have on SQL 17. So what I did is I talked to our development team and said, what are some of the little golden nuggets you threw in SQL 17 that may don't have the great notoriety of features we've talked about? And these are some examples. Indirect checkpointing is the default behavior now for a database in SQL 16 and 17 instead of the normal checkpointing process. Well, we discovered some scalability issues with it, hence this reverse scalability problem, and so we made some changes in SQL 17 that actually help in those scenarios. What about read-ahead and scanning algorithms? Well, analytic queries, by their nature, do scanning, which is okay, actually, in parallel. And so we found some scenarios where we needed to prove those algorithms. In fact, we even changed and optimized the size of read-ahead that we would do to a larger size for contiguous pages. We went after hot spin locks. If you don't know what a spin lock is, it's an internal structure we use to do concurrency protection for our worker threads. And so we have all sorts of techniques that we use to look at a workload to see if it's a performance problem. In fact, I was talking to somebody today at the clinic about CPU utilization. And one of the things, the tips that I gave them was that if you don't find an obvious query that's causing a lot of CPU utilization, go look at spin locks. Go look at the DMVs related to spin locks and see if you can pinpoint what we call a hot spin lock. We do this all the time in performance testing. And so we found some. We found some examples where we were doing a spin lock we didn't need to. One of those was a scenario where we would go into our code and check to see whether you were in a contained database for every query you ran. And it required spin lock. And so we said, we don't need to do that every single time you run a query. Well, it was amazing to us. We're like, why did we notice this before? Well, we had actually improved the engine code so much from a scalability perspective that we never got to that point that that mattered. So that's the kind of fine-tuning type exercise we were doing in 17. Now, what about the current attractions? What are the big things out there maybe you've been hearing about? Well, first of all, maybe you've heard we have this Linux thing that we've done. We're running SQL Server on Linux, and I think at a very great performance scale for OLTP and analytic workloads. Adaptive query processing, which we'll talk a little bit about later. Automatic tuning, which I demoed at the keynote. And then finally, one that just really slides by that many people don't realize is you can now do read scale availability groups without a cluster. If you just want HA capabilities and manual DR capabilities or manual failovers, you can set up secondary replicas for AGs not requiring clustering technology, and you can even do that across platforms. You can do that between Windows and Linux if you'd like. What about some other stuff that may not get, again, from a press perspective, from a performance thing? So graph database. If you're somebody that's used other graph technologies, one of those is Titan. We noticed one of our customers, a technology called Titan for graph objects. This customer observed 5x faster performance by moving this workload into the database with SQL Server associated close to the data. If you spend any time with Query Store, I actually attended, before my talk yesterday, a great talk by Erin Stellato on Query Store, and she talked about the fact that we've added weight statistics for end-to-end analysis. What do I mean by that? Well, now you have the ability to go in and look at a given query in Query Store and find out its total average duration, and then find out how much time was it taking CPU utilization and what kind of weights it was taking and what were the type of the weights. Or imagine running queries like, how many queries are waiting on page IO latching or write log waiting or something of that nature. So providing Query Store weight statistics give you now that end-to-end story for query performance analysis. What if you use a lot of SSIS work and you really want to get to scale? SSIS team now offers something called scale-up packages where you can literally run packages across machines in a method to get true amazing performance, and I've got some pointers for you to take a look at that. Maybe you've heard of something called SQL Server Machine Learning Services that we offered in SQL 16 with our support. And we did some amazing work with that, right? In a million transactions per, predictions per second type thing. Well, now we offer Python as a new type of technology for doing machine learning in the database with SQL Server, and we've got something called RevoScale Pi as a library of scripts that are like the R scripts to run Python at scale. But what's really interesting is us taking scoring technology, prediction type scoring technology, and putting that inside the SQL engine. So there are T-SQL primitives now that don't require the machine learning processes to run outside of SQL Server to give you built-in scoring capabilities in the engine. If you're really into that kind of type machine learning type model, please take a look at that. That's a pretty exciting release or feature we've got in SQL 17. And the column store indexes in Enroll TP, I get blue to your face about how great those technologies are, so we just keep making those better. I've got a couple of slides to talk more about that. So when you think about SQL 17 from a feature perspective for performance, this is really kind of the landscape of what we've added to what we've already done in a great release in SQL 16. So I told you I thought SQL Server was pretty fast out of the box, simple, built-in, and online. That's just my personal opinion, just from running certain workloads without doing a lot of tuning. And we really believe in keeping you fast online, whether it's indexing backups, altering a table, or doing consistency checks. One of the new features in SQL 17 for online index rebuilds is resumable online index builds. So now you have the ability to kick off an index rebuild, pause it, run it again, and it will pick up where it actually left off. That's pretty cool. So maybe you ran an index build and it takes a while or it's consuming resources and you want to pause it because it's causing some issue from other workload you're doing. You can actually pause that index. Let's say it's 50% through. We will recognize where you were in that process. We have all the things saved to do that, and we just kick off the rebuild after that point. But here's something that's interesting. I spent a lot of time talking about the SQL Server engine. And I myself, as I thought to myself, what is the stuff that we have internal to the engine that just makes apps scalable that no one really realizes? Or maybe we talked about it actually years ago because it's the base core of what we do, but people don't understand it. Things like buffer pull ramp up and read ahead. You know, these are technologies built inside SQL Server that you really don't even know is going on. They provide optimal scalability for your queries. We partition everything by Newman CPU. We're big believers in that. So when we have data structures or things inside SQL Server that cause scalability issues, we're always looking to see how do we partition these things either by a Newman node or CPU node. One of these things I talked about in SQL 16 was dynamic memory partitioning. So C-mem thread wait types. You know, it was kind of our goal to rid the world of C-mem thread wait types as a disease. And we did that with a technology called dynamic memory partitioning. Maybe you've heard me talk about SQL OS in the past in a talk about how we do efficient scheduling. We actually built SQL OS in a way, whether it's running on Windows or on Linux, to minimize context switching with the kernel. We do some really interesting things when we actually go wait with our worker threads so that we don't wait on a time, we wait infinitely so that the kernel doesn't have to worry about threads waiting on our schedulers. And they have other things on this list here. We parallelize everything, as you can imagine. In fact, sometimes, you know, max degree of parallelism and query processing in parallel is a thorn in some people's sides. But actually, we're a big believer in taking a look at any type of operation that we're running in the server and seeing, can we parallelize this and make it faster? One of the things we introduced in SQL 16 was the ability to do like an insert select in parallel, those kind of top operations. So whether it's a backup, recovery, we introduced parallel recovery, redo, bulk load, logging, checks, stats, you name it. We think in many situations that doing things in parallel makes a lot of sense to keep things scalable. Things like instant file initialization to keep database files created or incremental stats and partitions. All of those things almost require no changes by you to make your apps and SQL workloads run fast built in. So let's see something like that in action. You know, how am I going to prove that's the case? Maybe you've heard of a tool called HammerDB. Anybody heard of that before? Let's see, let's bring this guy up. And I apologize, I'm not sure if you can see the total view there. Steve Shaw and I, the author of this, I'm kind of interacting a little bit about how well will this display on high-resolution laptops. So what I've got is I've got a database on my laptop running SQL Server 2017 on Windows, and I've got a TPCC-like workload using the tool to build the database. It's not that large, but it is just running on my laptop. You may be asking yourself, like, well, big deal, that's not my application workload. But these type of tests are actually really interesting because it gives you the ability to see the capabilities of SQL Server in your environment. How will it run in my hardware if I configure it a certain way? How will it run if I add certain options like availability groups or I throw indexing on top of it or something like that? So I love these kind of type tools to give you a baseline or a thought around what will typical SQL workloads look like. Now this one, this TPCC, is a little antiquated in some of the queries it does, but it's still a representative of an old TP workload. So let's kick this thing off and see what it does. So the way, if you've not used this tool before, it's a quite nice tool, is I'm going to go and load up what's called this driver script, which tells me which server to go to. And in this particular case, I'm going to run, I've got an 8-processor laptop, so I'm going to run 8 users. Get them ready to go. And then I've got this little, it's got this little handy tool over here to kind of monitor its performance. So I'm going to have it refresh every 2 seconds. So here we go. Now this thing's going to kick in, and already I'm at 600,000 transactions per minute. And all of a sudden I'm at 1 million already. Now if you didn't know what this is doing, this is looking at batch requests per second. So this is somewhere in the neighborhood of 15,000 batch requests per second with the client and the server all running on the same actual virtual machine. And again, you're asking yourself, well, big deal. I mean, you know, I don't have apps that actually look like that, but you might be surprised when you look at the queries it do. So what if we threw some stuff with it? Like what if we did something fun here and said, okay, I'm going to use the new XE profiler. Has anybody seen this? In Management Studio, you have the ability now to go into, quickly click on this and do an automatic live trace, just like you would do with SQL Profiler. So I'm going to kick that off. And you see my workload has some impact a little bit to what's going on, but it can still stay pretty consistent, almost 1 million transactions per minute. But I really don't understand what some of these are doing, so I'm actually going to do something like a tool like Query Store. I'm going to go in here, and I'm going to enable Query Store. And I'm going to go see, my workload's starting to get a little bit of impact now by running a trace and Query Store, but it's still close to 1 million transactions per minute. And then I can go in here to the Query Store and then look at my reports to see my top consuming queries. So there you go. I'm consistently getting almost 1 million transactions per minute while running a live trace on my laptop, while running a Query Store. That is pretty cool. That is pretty neat type stuff. And that's all built into SQL Server. I made no changes to SQL's configuration to make this happen. I just installed the database through HammerDB, ran this client workload on my laptop, and then I'm doing tracing. So if you don't have confidence that you can do things like tracing or Query Store, go run tools like this and see in your system the impact it would have. Because in my system, even on my laptop, with the client and SQL Server all in this box, I can do it. Now, you should hear the fan running on this server here. It's actually pretty hot. It's actually flying along. So we don't want any other laptop issues like I had yesterday. So, but check it out. You've got XE Profiler now as a tool for helping you doing tracing. You have Query Store to go take a look at the statistical analysis of the queries. And then you yourself could go hammer your laptop or your server with something like HammerDB in a very simple fashion just to see the capabilities of your hardware, your configuration, or by adding knobs or certain things to SQL or availability groups or backups and see what is the impact of running a high-powered workload on my system with these tools. So there you go. Let me stop this. And listen to my fan die down a little bit here. Okay, I'm going to turn Query Store off for that database. Okay. So that's me putting a hammer to my SQL Server on my laptop. So I told you, besides the fact that it's fast built in, it can be faster than you actually think. We are fast on Linux and even containers out of the box. This #1 TPCH benchmark with a 1 terabyte database, the first benchmark we actually released for SQL 17 was on Linux. We did it for a very specific reason, because people did not believe that we could actually deliver SQL Server on Linux in a 1.5 years and make it fast as Windows. I had a question from somebody that came to me in my talk yesterday saying, should I run Linux? Should I run Windows? Which one's faster? And my answer was, don't use performance as your decision to run on one of those platforms. Maybe Linux or Windows has certain properties that help you in your environment, but it's not SQL Server's performance of the reason we did that. It was a choice for you. If Linux is your preferred platform, we run really fast on that. If Windows is your platform, we run really fast on that. And we are committed to making SQL Server run great on both platforms. So if you see the benchmarks we released, you're going to see a mixture of benchmarks on either platform that we're going to do, just to show that we're committed to both of them, but that especially we can run on Linux for those that were kind of questioning, can you actually do this? Certainly column store indexes. Column store indexes is the #1 feature for SQL Server that when I talk to audiences and customers, that is not used in an analytic query environment. How many of you are deploying clustered column store indexes on a warehouse or read-only environment today? How many have a read-only environment where you're not deploying clustered column store indexes? And this is not a shame session, like shame on you for not doing that. I hope, though, even just with some of the simple demos I have to show you why it absolutely matters and it's really a technology you should take advantage of. In memorial TP, I get you on that one. That's a little bit more of a more difficult choice. I encourage you to come tomorrow at, I want to say 11:30. I got invited to be on a panel with Ned Otter and other folks in the industry at Microsoft to talk about this technology tomorrow. What about write log waits, which indicate kind of transaction log latency? Now, there's a persistent memory technology for Windows that's different than what I demoed in the keynote that you can use to actually speed up write log waits. And where it says write log waits equals 0, the funny story is that when we first tested this, we were using dmexec requests to measure and just see what waits were occurring with our workload, and we thought we had a bug because write log would show up with a value of 0. And so we said, that's got to be a bug, right? I mean, it's a 0. Well, it turns out it's less than a millisecond, and that's the counter in dmexec request, which is a millisecond. So we went to extended events, which is in microseconds, so we can see the actual performance. You can load data very fast in parallel with minimal logging. I think we have excellent tools and recommendations how to do data loading at high speeds with SQL Server. And one of the things that the Tiger team loves to do is delight you for things on existing releases for just little annoyances. So they remove that silly trace flag so that you can do data loading with clustered indexes at a fast speed. And then we know how to tune Linux for performance. I've got a pointer in a few slides. We spent a lot of time going through very specific Linux settings that make sense only in the Linux environment to make sure you get the speeds that you need at reasonable performance rates. So what can I tune for better performance? Here's what I did when I built this slide. I did this presentation also on Microsoft Ignite, and I thought to myself, and I talked to some other experts, MVPs, folks in Microsoft. I said, if you do make tuning changes, what do you do? What are the most common things you would take a look at? You may look at this list and you may say, I've got other things, but what is most common across this industry? Well, #1, it has to do with indexing, right? Usually it's all about trying to build the right indexes, looking at things like partitions. If you've got large-scale read-only type workloads, you have to take a look at partitions, and statistics, making sure statistics are the right for your workload. But there's other things I think that people just forget. Like even things like, how about just using stored procedures or parameterizing your queries? Max server memory and max degree of parallelism. These are probably the most two contentious configuration settings I've seen in my career, but they are ones that people take a look at to decide, should I tune something? For example, max degree of parallelism. If you've got a pure OLTP workload, you could make a case to say you should set that to 1. You could say that. Like, I don't want any parallelism in this system because I have no queries that would even need that. But if you're running on a data warehouse, you don't want that at 1. You want that to be at a higher value. Could be 0, but it could be a higher value that's going to give you maximum scalability because that's very common for data warehouse workloads to use query parallelism. Max server memory is a good example. You may play with that number to decide how much do I give memory to SQL Server versus leaving it around for other programs and the operating system. Multiple temp.db files. Is there any more other debate in the industry than about multiple temp.db files? Maybe max degree parallelism is that. But think carefully when you make this decision. The typical reason you're creating multiple files is not a decision for I/O typically. It's a decision to partition our allocation page structures to give you less concurrency and contention when you're doing a lot of temp.db activity. And I still stick with what I've been saying for years, and that is start with something like the number of CPUs if it's like 8, and then add by 4 until you see a point of diminishing returns. And I've done plenty of talks to kind of talk about what that should actually look like. Right-sizing the transaction log to avoid auto-grow. I cannot tell you, I talked to the support team about this one, how many times customers call and usually some sort of auto-grow situation has occurred with the transaction log, which can't use instant file initialization because of the nature of how we do and read the transaction log, and they've not right-sized it, or some unexpected event has occurred, and so an auto-grow kicks into a very large log size, blocking the entire application. So ensuring you right-size that is actually really important. And then target recovery and automatic checkpoints. I mean, there's a decision to make there to use these technologies. Automatic checkpoints in the normal checkpointing mode does sometimes have the undesirable side effect of huge bursts to your disks when a checkpoint operation actually occurs. Whereas the idea of doing target recovery or indirect checkpoint is more of a steady stream of writing checkpoint operations to your disk. So there's some choices to make there and deciding what to do. And then finally, what about this one? And there's some debates I've seen about whether this makes sense in your environment. But if you've got blocking problems, you could make a case to say that you should turn this on, read committed snapshot. Now, you have to decide for your workload whether the results you get back is what you want from that. But you certainly should take a look at it. So to me, these represent the most common SQL server type config parameters or tuning that customers do across the board commonly. Now, what about things not related to SQL, but are kind of related to SQL, if that makes sense? Well, certainly from a Windows perspective, there's this locked pages concept and instant file initialization. I will make the bold claim to you right now that if you're running on a Windows Server, there's no reason not to use these options. I'm happy to debate that all day long. You should use locked pages and instant file initialization. Now, for Linux, it doesn't make sense to use those. Those actually don't apply in that environment. Instant file initialization on Linux is actually the default behavior of the operating system, and the concept of locked pages doesn't actually even exist. So it doesn't even make sense, and you don't have the option to turn that on anyways because there's no registry for you to touch. Here's another one, high performance Windows power setting. Has anybody ever run into a scenario where this is not on your server? I've seen it. They're looking at a show of hands. So anyone who's asking around like, what, is anybody actually run into this? Please double check this one. Again, that's a great support story from the CSS team. And then finally, this is another interesting, data and log directories somewhere not on the operating system disk. You may be looking at this going like, Bob, of course we do that. But a lot of people really don't know that makes a lot of sense. So separate those out because you don't want I/O activity on data and log affecting OS disk. Yes? Yes. The question is that on Hyper-V and VMware client, what do you mean by client? Oh, the guest, the actual operating system. The question is that does setting those inside the VM guest itself have an effect? And my understanding is yes, that I don't think you want those to be set on because Windows looks at those, right? The actual operating system pays attention to that setting and could do something to even the virtual CPU to actually make it slower. So I make sure that that setting is on no matter what environment I'm actually running on. And then finally, I told you about Linux best practices guide. I'm not going to go into the details there, but there's a lot of interesting settings. I'll just throw out one at you. If you're running on Red Hat Linux Enterprise, there's something called profiles, which are default Linux settings for maximum performance, and we rely on something called throughput performance. So if you go look at throughput performance in the documentation in Red Hat, it shows you what those settings are, and we've got those in our documentation to say, yeah, we agree with those. Use that setting as a default. So if you run on Red Hat, for example, that's the #1 thing you should go do. Or if you're on Ubuntu or SUSE, go use those same settings manually that Red Hat provides in their profile. Okay, this is a slide that I added. It was not in Microsoft Ignite. So it's a fun story. When I was at Microsoft Ignite, I talked to the team that built the technology that you know as performance recommendations in Azure SQL Database. These folks are from Serbia. They're really talented people. And I happened to have lunch with them. And I said, you know, I've often wondered, like, how do you guys do that? How do you do this creating indexes automatically and so forth in Azure Database? I'm interested to know the intricacies behind that. And they said, Bob, actually, there is some complicated algorithms involved, but it's a little bit simple. What they do is they use the missing indexes DMV. Now, it's interesting. That DMV came out many, many years ago, and I think it's got a bad rap. And that is that people go and look at it and say, I don't like these recommendations. I think really the bad rap is that people don't want to default just apply everything it says, and I totally agree with that. So here's what they did. They collect the missing indexes DMV over time for your database in Azure, so they would collect it on a certain frequency, and then maybe for like a week of time, they'll collect it. They'll put it in their own little database. And here's what they do. They filter out some of the index recommendations they think that don't make sense. They apply some mathematical models, which is actually fairly a little bit complex to that, and then they merge together what they've collected over time to create a set of recommendations. And that's when you go to Azure Database Portal and say, oh, I'm recommending you create this index, right? Or if you turn on the automation, they'll just do it for you. Now, what I love what they've done, though, is what they do is they do validation. So they use the query store to monitor the queries associated with those indexes and decide, is it running better or slower? Or is it causing performance problems, or is it faster? And that's where you see the recommendations sometimes where they drop the index, or they do it automatically or recommend do that. So that's the basic fundamentals of what they do. And the reason I put this on this slide is I want you, if you're managing your own SQL Server environment, to consider combining yourself these technologies. Look at missing indexes DMV. Don't just blindly apply them, but don't discount that. And then maybe look at performance as you apply indexes to the query store. If you record when you apply your indexes, use the query store to look at the differences of when you did that and look at the queries that are affected by it and then decide whether you should keep them or drop them. Yeah, your question.
Yeah, you mentioned that they monitor the query store queries associated with that index.
Mm-hmm.
Do they also look out for queries that unexpectedly start behaving differently before you when you create them?
Yes, so the question is that, do they look for unexpected performance differences from new queries that have kicked in that didn't kick in before? Is that what you're asking?
Queries that suddenly got a new plan.
Oh, like planned regressions. Yeah, absolutely. They look at anything. They look for performance differences for queries affected by these indexes, good or bad, over time. And they call it their validation phase. So again, when you go to the portal, you're just going to see these recommendations. Or if you say auto, they just do it for you. But this is behind the scenes what they're doing. So take a look at Mrs. Index of DMVs. If you've discounted that in the past going, I don't want to pay attention to that, go back and look at it again. There's actually good stuff in there. Don't blindly apply them. I'm not telling you that. But combining these technologies is actually pretty interesting. The other thing they do from a recommendation point of view is parameterize queries. So one thing we've observed over time in SQL Server, whether you're in support or whether engineering team, is customers have what we call ad hoc query workloads that really don't need to be that. Just because of the nature they've written their app or a framework they're using, a lot of queries get generated that look very similar with the same where clause, just a different value, right? And these things are not auto-parameterized, so they end up in this scenario where you've got a lot of execution counts of 1 for like a bunch of queries. So how would you detect that? How do they detect that? Well, they use the query store, and this is how they do it. They look at the query store text DMV, or the catalog, and they recognize that there's a lot of rows in there that map to the same query hash in query store query with an execution count of 1, because we record that information in the query store. And then they also look at many rows in the query store query DMV that may have the same query hash plan and query store plan. So they're just using queries that you could use yourself in a query store environment on your SQL Server to detect this pattern and decide, do I need to parameterize my queries? You could use force parameterization, which is a database option, or you could go take a look at the app itself and decide, should I do that? So that's how they do it. It's not that complicated of how they built this together. What I love what they've done is they've used the query store and the existing engine technologies that you have access to make these decisions. Now, they've got some logic they put into it, which is intellectual property for the Azure team, which I don't have to share with you. But I want to make sure you're understanding that we have technology built into our product that you can use yourself to make these decisions. Okay, what about column store? Like, what does it matter? Look, I'm a really simple person. We have so many smart people at Microsoft, way smarter than me. I actually had dinner last night with Slava Oaks. Wow, that was crazy. So I looked at column store myself as a technology, and I thought, why does it matter? Like, why would you actually use that? And here's my simple explanation. Well, number one, it's a better data compression technique than row compression or page compression, because columns, by their nature, similar values compress better than rows. And if you didn't know this, they're compressed on disk or in memory. So if you don't have enough memory to even support loading the entire column store indexes from your table, that's okay. I mean, it's not as optimal, but we still load compressed indexes column store on disk or in memory. And there's actually DMVs where you can detect how we're actually doing that. Then we have this concept called column elimination. Most production application workloads that are good, I'll put that in quotes, don't use select star, right? They use a specific set of queries that they're going after. So why would you go after and go read columns that you don't care about? And so column elimination is another reason to use this technology. And the really big one is something called row group elimination. Like, why, when you're scanning this massive column store index, should you go after rows that you don't care about? And so they have this concept called segment skips and segment reads that you can take a look at. So skip rows you don't care about, and then combine this with table partitions. And then finally, when we run query processing operators against column store indexes, we have this concept called batch mode, which is very, very good. And the idea is doing operators in the query processor against groups of rows versus one row at a time. And then right now, batch is only supported with column store indexes, so another reason, though, to consider using this technology. In fact, I have a pretty bold statement. And I'm sure I could get debated all day long on this, but if you've got read workloads with greater than 1 million rows per partition or just per table, why would you not use this technology? There could be reasons why, like if you have heavy deletes against this. Notice that's why I said a mostly read workload in a warehouse. This technology makes perfect sense. And I was challenging the team I met with, the auto-indexing team from Azure. Why don't you do that for Column Store? Why don't you take a look at the workloads in Azure Database and come up with a model to automatically recommend and apply Column Store indexes? And they're like, that's a pretty good idea. I think we'll look at that. And they actually said, we could have prototyped this before, but maybe we should revive this again. So that's my case for using Column Store indexes. And so I've got a discussion here on MMLTP, and then I'm going to show you a quick demo about Column Store. So without going to too much depth about MMLTP, I have a couple things for you to take away from this slide. The biggest thing here, it's not about memory, even though it says in memory LTP. Sure, everything has to fit in memory to use this technology, but it's really about optimized access to the memory. You could create a workload of SQL Server rows in buffer pool cache that fit all in cache. That's in memory too, right? That's not on disk. But it's not about the optimized access in that case, because you still have concepts called latching that have to go after these pages and other things that may actually deter from a high concurrency workload. So in-memory LTP is all about optimized access, and it really shines with concurrent workloads. If you try to go off and do a test and do a simple single user doing an insert against a disk-based table and a memory-optimized table, and you come to me and say, see, it's not as fast, it's not faster, I'm going to say, okay, you're right, but who cares? Now, go off and do that same test with 100 concurrent users and come back to me. When I've done a talk before on OLTP, which I did last year at PASS, I've got easy little demos to just prove to you that you can use a tool like OStress, go after like 25 concurrent users on your laptop, and I can just beat all day long a disk-based table versus memory optimized. But unfortunately, to me it's unfortunate we called it in-memory LTP, because sure, it is about low latency LTP needs, but look at these other scenarios to consider. IoT feeds, staging tables. If you're caching something, you might have an application workload where you need to kind of cache data and use SQL Server itself as the cache. Like, why not just use SQL Server tables as that thing? So you don't really care if SQL Server gets restarted and you lose that because you can repopulate the cache. Well, schema only has no logging requirements in the case of memory optimized tables. And finally, this is the one that is discounted, and I saw a lot of use of this in SQL 16 is table types. You have the ability now with a table type to say it's a memory optimized table type, and we will no longer use tempdb, we will use actually a memory optimized table to store that information. And so if you do run these type of workloads, even concurrent, and you'll notice you're not getting the performance that maybe I'm claiming, like up to 30% or 30x, take a look at the transaction log, because when you're using schema and data, which requires durability, it's usually the transaction log that causes latency issues. I'm a big believer in customer stories, and I did pull this off our website where we actually talk about different customer testimonies, but I wanted to go in and see what they said. Like, what were the phrases they said? And look at the things I pulled out. DV01, a customer that made a move from Postgres on Linux to SQL Server on Linux. And the reason they did it is because Postgres no longer met their performance needs, but they didn't want to go to Windows. They were a Linux shop, and so they loved the fact that orders of magnitude performance differences by going to SQL on Linux. Channel Advisor, a customer we work with a lot, who used MMLTP and achieved a 75% reduction in their workload processing by just moving to that technology. But I love this last quote. Fidelity Investment Services, not Fidelity, the big Fidelity company that I use for my 401k, but Fidelity Investment Services, which is a multinational company. Look at this code. With non-cluster columns for indexes, we didn't have to involve our DBA operations team or programmers or SQL query writers. We just applied them, and we got 20 times faster performance in some cases. So that's not a quote to say, oh, I don't need a DBA. It's a quote so that you understand that column store indexes for read workloads can be very significant. So let's go take a look at a demo and example. No one's probably ever heard of Power BI. It's this kind of popular reporting tool out there. So my friend Adam Saxon, I'm going to make him proud here. So here's what I've got. I've got 2 Power BI dashboards that I built. And I built these on top of a workload in a database that looks like TPCH, which is analytic type query workloads. And so what you've got is a visual map that is representative of one of these queries that you might see in one of these benchmarks. So it's kind of an analytic type query workload. In fact, this is showing like shipping priorities, like where have we got scenarios where we should be doing a more priority on shipping our goods because we're losing money. And so the bigger circles represent that. So this is the database that's kind of like without column store indexes, just normal indexing. And I can refresh this by clicking on this data set over here and just hitting refresh data. And you'll notice this comes up, and it just takes a couple of seconds to kind of evaluate. And what it's doing is it's doing a direct query against SQL Server itself to go pull back that data. Now, that's interesting if I just have one user using this. But what if I go in, and let me get the right query here. Yeah. So what I've done is I've taken that same query that populates that visualization, and I'm going to run this with multiple users using a tool I use all the time called OStress, which you can download for free on the internet. So here's what I'm going to simulate. One user is one thing. What about 10 users all going out there and trying to go hit the same report? How is that going to behave? So I'm going to go kick this off. He's going to run. I'm going to go back against this, and now I'm going to try to refresh this again. Now your reporting user's a little bit frustrated because he's trying to refresh his report against this Power BI visual, but it's taken forever. So one user was fine, but you have multiple people hitting the same direct query against SQL Server. That's not healthy. That's not good. So let's show it a different way. Let's go back and stop this OStress workload. Now my other dashboard that I have is the same exact data, the same database itself, identical, except for one difference. I applied cluster column store indexes to the largest tables that exist in this database. If you notice the number on the right-hand side at the bottom there, notice it says 8,000, and you go back look at the other report, you notice this one says 16,000. So that's 16 gig versus 8 gig. That was the compression ratio I got on this database by just applying the column store index. I got 2x compression just by doing that. So let me go run the clustered column store index one. Let me go refresh its shipping priority. And it comes back like you don't even know the difference, right? I will go run now the multi-user workload and see what I get. Here's faster. It comes up. It does take a couple of seconds, but you'll notice here pretty quickly it's going to just finish. So the other one, by the way, that other one, I've let that thing run. It takes like 2 minutes to finish. This takes just a couple of seconds. That is the power of by just adding clustered column store indexes for Power BI type workloads. So I'm trying to instill a sense of trust in you that you could actually point a Power BI set of users directly against your SQL server if you're running clustered column structures. Let me show you another example that's interesting. So maybe you could say to yourself, well, Bob, that's interesting. I could create a canned visual that I only let my users use there, and that's not a big deal. But what about they start doing things like this? They start dragging and dropping stuff, and you get really nervous. You're like, I don't know. So I'm going to drag this over here, which is a market segment list. That was pretty easy. But what if I take the sum of line item, like this is a sum of all my line orders. Now, you can't see it here. Maybe you can see it, but it's spinning. This is running now a scan against my database, trying to populate this visualization. And it's taking a while to actually do that. And it's eventually going to come up and it's going to finish. Now, when it finishes, though, that's interesting. That's not that bad as a single user. But what gets really crazy is, do you see all these little visualizations? If you've not used Power BI before, this is a way to take these visualizations and look at them in a different way. Like maybe by a table. Now, you see what's happening? I just took what I put on there and changed the visualization type. Power BI in some cases has to go back and query the database again just to do that. So all of a sudden now you've got a very frustrated user in your hands like, look, I'm trying to use Power BI against the database and warehouse you built, but it's taken forever to do that. I don't like that. I don't blame them. Let's see how our column store index behaves. So I'm going to do the same exact thing. This is kind of a market segment analysis of my orders. And I'm going to pull this over right here. You notice it was instantaneous. And if I go over and start clicking things, these visualizations, I get like no delay. And I'm telling you, you don't believe in me, but some of these are actually, like this is all cached, right? No, these are running queries. If you go trace this, every one of these clicks is running a query right up against the database. This is not a large database I built, but then this is all against my laptop. And in fact, just to kind of prove that I'm serious here, this is all running against Linux. So I'm actually running a Linux VM in Hyper-V on my laptop with Power BI on my laptop hitting actually that server at the same time. That's pretty cool stuff. That's showing that SQL Server can handle, in my opinion, Power BI direct queries using cluster and column store indexes. And the only thing I did is take the same database and just apply clustered column store indexes to the biggest tables I have in my workload. That's all I did. I got 2x compression, and I got really high speed for huge scans that are out of your control as a DBA that come from these report users. So take a look at column store. I think it could be very valuable to you. And if maybe, today you don't believe that column store is possible, maybe just even look at a simple demo, and these demos are all available for you to download and run yourself, you can become a believer more that column store is a technology I really need to take a look at. Okay, that's column store. Okay, we're doing good on time. Is there any questions at this point on anything I've talked about column store or anything I've just demonstrated to you? Wow. Do I need to put a debugger up or something? I mean, what's going on? Yes. Right there. You had your hand up? I can't hear you. I'm sorry. Because I'm old. What's that? I'm sorry, dude. I just can't hear you. You got a soft voice. Just yell it out. Oh, you mean would we do batch processing on non-column store indexes? Don't know right now if there's any thinking about removing that limitation. Right now we're focused just on column store, so I'm not sure about if we're going to do that or not. Yeah. Sorry, dude. Can't hear you. I mean, I apologize. I haven't any mics, so. Non-clustered index on a clustered column store index, is that your question? That's a good question. So I love the fact that we added that feature. So one of the things about clustered column store index is that there's no key, right? There's no primary key uniqueness. Well, this is why we added that functionality. So if you need primary key uniqueness type opportunities, create you a unique non-clustered column store index on your key value, which gives you amazing seek capabilities, right? So when you have seek queries against the same table, where you have these scans going on, you combine those two technologies together to get the best of both worlds. Yeah?
Sparse columns. So column store indexes doesn't support sparse columns, right?
That's true. I'm pretty sure you're correct about that. I don't know of any plans to make changes to do that. Okay. You have a question? So the question is SQL Server 2017 going to be available on managed services? I'm assuming you mean our managed instance database in Azure, our preview? Okay. So thank you for that question. It's a good question. So we try to do a very good job of keeping the code bases the same in these technologies. In fact, in a lot of cases, we go innovate in the cloud first, and we put it on premise in our box, right? So there could be some features that we put in 17 that won't be in managed instance, but for the most part, that's one of the reasons we're doing that technology is to kind of open up the surface area for you from Azure Database today to get access to features that you didn't have access before. Okay, so keeping you fast and tuned. Really cool technology called adaptive query processing. So I told you in the keynote, and I realized it was kind of a shortened keynote, you were probably all blown away by the Cowboys jersey. That's probably what distracted you from all the great demos. Rohan was a great fun doing that with him, actually. So I think you're going to see us, and Connor kind of alluded a little bit to this, and Connor's kind of one of our key architects to make these decisions. I think you're going to see us more and more take opportunities to put more intelligence into the engine and things outside the engine to make things easier for you. Not to replace what you're doing, but to make it easier for you, right? So adaptive query processing is one of those technologies, and the idea is that can we, inside the query processor, make intelligent decisions to either build a plan that can be flexible, things like adaptive joins. Imagine a query plan, this is crazy, that has a query plan operator that can make a decision on the runtime to go one join path or the other. Nested loop joins or a different type of join, depending on the query. That's pretty crazy. Or this one I really love, which is insufficient memory grants, which is a huge pain in many, many people's customer problems. So imagine not having spills to TempDB anymore because of memory grant problems. So an idea where the query processor can learn from itself, detect a spill problem with an insufficient grant, and then the next time you run the query, without recompiling the plan, actually fix that problem and give the right memory to avoid that problem. That is pretty actual cool. The one you saw in the keynote, which I have a whole slide to talk about in a second, is called automatic tuning. And then finally, don't discount the query diagnostics that we've made heavy investments in, whether it's live query plans, query store weight statistics that I mentioned, or even little things like this. In Management Studio today, you can take a given show plan, a graphical show plan output, and you can right-click and say, analyze my plan for me. And one of the things we'll point out for you is whether the cardinality estimates and actuals are actually different. So we're trying to put more intelligence into the tools and in the engine to give you recommendations and make your job easier. Somebody had to raise their hand. Yes? The question is that, does automatic tuning take care of parameter sniffing? You know, the check's in the mail, sir, because I'm going to talk about that in the next slide. So automatic plan correction. Sorry, you had a question?
Yeah, on the adaptive query, will it
Yeah.
go the other way? If you allocated too much memory.
Andy's question is that what if we did too much of a memory grant? Right now it's just for insufficient memory grants to avoid spills. So the comment from the experts in the audience here is that it will actually do both. I did not know that, so thank you for correcting me. So it looks like it'll handle both scenarios. One thing, though, that I want to point out in all transparency is that this is for column store index scenarios today. So you need to be using column store batch mode type scenarios for us to apply this today. But we're looking at how do we actually extend this technology to be beyond that. So thank you for pointing that out. So imagine this scenario. You kind of heard a little bit in the keynote. This is kind of a graph of how you're running along. You've got SQL 17 now deployed. You turn on query store. That's one of the requirements for this. And then query performance is running pretty good. And plans might change over time, but then boom, a new plan kicks in unexpectedly and performance goes south on you, right? So here's kind of the concept. Query store is enabled in 17. By default, without you doing anything besides turning on query store, we will have a background process that will monitor and detect, is there a regression? Well, what do we mean by that? Well, we've noticed performance gets worse, and we notice that the query plan changed for a given query in your situation. Why would that occur? Parameter sniffing. Some unexpected event occurs in your system. Usually it's memory pressure that causes us to have to evict some plans from cache. And then a new plan kicks in because a stored procedure is run with a different parameter value. And that plan is okay for that person, but not good for everybody else, typically. That's kind of the scenario you're running into with parameter sniffing. And so that's a common query plan regression scenario. So by default, we turn on, or we have this DMV where you can see recommendations for us to see whether we detected these problems, and then we will give you a recommendation on how to fix it yourself. So what if you turn on the feature? Notice the syntax here. Alter database current, automatic tuning, force last plan good on. Okay, the concept there is, instead of the default setting, you're going to let us detect and fix the problem for you. So now, instead of just recommending something for you to look at yourself on an ad hoc basis, we would detect it, look at the recommendation, and actually fix the problem. And what I love about this is that we'll validate what we did. We monitor kind of in a cyclical pattern. Is what we did good? Is it okay? Did it cause worse problems? Do we need to revert that back? This concept, though, is called last known good. This idea of actually reverting back to a query plan that was faster for you and now something that you want in your environment. I've heard some commentary about some folks saying this is not a permanent solution, and I kind of agree with that. I would say that if we turn this on, or you turn this on in your environment, and then you detect that we did this, you should go to investigate why we did it. There could be something in your application, your index design, or something that is a better long-term solution than us doing this. But you might have heard in the keynote my scenario for you, like maybe right now. You know, if you had one of these problems happen right now, you have to go run away, you know, outside and go fix it yourself, right? But wouldn't you rather get an email like tonight saying, what was this blip in the matrix that occurred here? A small little blip of performance occurred, but things went back to normal. That would be a better scenario, right, than getting woken up in the middle of the night to the next day kind of investigate the problem. That's kind of what we're really going after here. So let's go take a look at it. Let's spend more time than what I did in the keynote looking at this problem. Let me get rid of him. Okay. So I'm going to bring up, actually, in Management Studio, you saw me run in the keynote a series of commands. You're like, hey, what was that? He just clicked a couple of buttons and things worked. So first of all, I actually took the Wide World Importers sample database, and this was a scenario provided to me by the team that built this technology. And so what report.SQL looks like is, whoops. Looks like something like that. So there's a procedure called report that we added that takes an integer parameter, and it runs a query against tables in the Wide World Sample Importers database. And notice in this case, I'm declaring a fixed value of 7 and just running this procedure. So when I run report.cmd, I'm just running a bunch of users running that same stored procedure all just in a loop, just running this as fast as they can, like 10 users or something like that. So that's what I'm doing. The regression script that I ran looks something like this. Okay, that particular procedure, I'll show you what that looks like, called regression. That isn't here. It's going to do a DBCC free proc cache, and then it's going to go run that same sort of procedure with a 1. Because in this contrived sample, I know that a 1 is going to give a plan that's good for the 1 but bad for the 7. Okay, that's parameter sniffing query plan regression. I use free proc cache to force eviction. In your environment, you would not be running this, obviously. But you could do something really crazy, like what if you did an SP configure change or alter database change, which in some cases we actually force a procedure cache of all plan cache eviction, or memory pressure kicked in, and something happened where that plan had to get evicted. So this is an example of a way of actually simulating what's going on. So let's run this, and you can see it again. We'll talk about it. Let me bring up this recommendations DMV I talked about. Now, this is provided for you in the documentation. And it's also in my demo. So I don't want you to what's that syntax there? This is the main DMV, DMDB tuning recommendations. And in there is some data that has guidance for seeing what this possible regression can look like. Right now it's blank, because we haven't detected anything. So let's kick this off. And I realize again that the keynote was pretty fast. We're kind of encouraged to kind of tease you and give you the idea, and then you see the details later. So this is just batch requests per second. I'm just going to run that procedure workload as fast as I can and just measure performance. So let me kick that off. This is using that OStress tool. And you start seeing I get a certain throughput of performance. It's not huge because I'm just running this on my laptop. And if I run that regression procedure, I'm going to go free proc cache, right? And then it's going to run the other store procedure. And then you'll see very quickly that performance goes way down. Now, why does it go down? Because the 10 users are now using a new plan that's very bad for that plan. It's a much slower. So overall throughput is affected. This might be a very common for you scenario to run into, right? That's not good. And then I said by default, we do recommendations. So if I run this query, you're going to see something that we've detected. We've detected that the average CPU time has regressed from 127 milliseconds on average to 612. That's not good, 6x slower. Now we pick average CPU time for a very good reason. If we pick duration, there could be unexpected events that you really don't want us to make this change, like some sort of I/O issue or something that's like an anomaly, not a constant problem. So CPU is what we're going to choose for this decision. And then just like I showed you in the keynote, we're going to give you this script, which is actually using a stored procedure provided by the query store, which you can run manually, to go force a plan. Now, if you had SQL Server 2016 in your environment and you didn't have this, you could manually do the same thing. You could run your own queries against the query store to detect a plan regression and then decide to force a previous plan that looked like it was better. We, quite frankly, are just automating this inside the database engine itself. But remember, the default behavior is for recommending, not fixing. And then you decide to fix it yourself. So when you look at my scripts for initialize in the demo, that's just clearing the environment. I'm clearing the query store to kind of reset the repo up. The auto-tuning script is just setting on that last force good plan option. That's all it's doing. So let's go do that. And if you notice here, the recommendations are cleared. So let's run report again. I've got my workload up. And then I run regression. It goes down, and then it turns on and goes back up. So what happened in this case is, because I turned the automation on, that background process that's doing those recommendations is noticing the recommendation. Because you said to do it automatically, it will look at what the script effectively recommends and just do it for you automatically. And then if you wanted to see that behavior, you could look at the reports yourself in Query Store. And you can see, zoom it, baby. You can see the example how we actually did a force plan for that situation. You yourself could force this manually if you wanted to and actually see that same type of behavior.
Bob,
Yeah.
in that query there you have a score. What is that score?
Oh, the score and the recommendations?
Yes.
Great question. I've asked that question. The guys who've built this have kind of said they prefer to not reveal the details of scoring systems and stuff, not because they don't like you, but because they're adjusting that. And in fact, they've adjusted that score. This is a really good question you asked about the scoring thing, because when they first put this in the cloud, they had a different scoring system, right? And they keep adjusting that. And so before they put this fully in 17 and baked it in, they were tweaking that scoring, right? And they have said they may continue to actually do that to kind of refine it. And that's one of the things that cloud gives them an advantage. They can run this technology in the cloud with Azure Database and monitor hundreds and thousands of users how this is operating and decide, is our scoring system any good? And if it's not, we'll tweak it. And then if we feel like it's a really good place where it's tweaked right, we'll put it to like an accumulative update or something. So that's why they've said they'd rather not go into the details of the scoring system. So, yeah.
So if I have more ad hoc queries, that's the procedure. It won't work, right?
So the question is that, do I have parameter sniffing with ad hoc type queries versus stored procedures? And the answer is, of course, no if they're not parameterized, right? So if they're ad hoc queries, they're not affected by something like this. But then you have to ask yourself, is that worth it, right? Because doing ad hoc queries may not be a great, it fills up procedure cache, right? And you're just wasting spaces in cache. So it is a downside of procedures. And there's a lot of techniques for parameter sniffing out there that the community does a great job talking about, using different hints that we've got and so forth. This is not a cure-all. This is just kind of a technique to kind of help you. I really view this more as a technique to help you during emergency situations, right? For you to not get woken up in the middle of the night.
But the procedures will have object ID, but ad hoc query will not have the object ID, right?
So that's all related in the query store. The actual queries that are in the store procedure, you can actually see the relationship with that of what object ID, what procedure they go with. That's all in the query store. Yeah.
So will this only use previous plans that it knew about, or like if you have a sort of a fast query, will it just like figure that out? Like how can I make all the help plans?
It's going to reverse to the last known good, right? So the last known, it detects the regression between one plan to the next. So query plan 3 was in for this query. We went to 4, things got worse. So I'll go back to 3 that I thought was good performance.
Did you evict the execution plan cache though?
I did. Thank you for that question. The question is, but you evicted the plan cache. How does it know the previous plan? It's stored in the query store, because the query store is stored on disk, which is awesome, right? So if we just use DMVs, this would be useless. So thank you for asking that question, because query store is a persistent record of our query performance across history, and so we just can look at the actual database itself and get the results. Pretty cool. Yes?
Follow up to his question, that there is no stored procedure, but there is an option available in .NET, like in C# and all, developer write on fly the SQL statement, and that is how we handle that.
Yeah, I understand that development frameworks use ad hoc query plans and not stored procedures. I'm just making a case for you that if you do use stored procedures, this is one technique to kind of help you. So let me move forward and kind of finish up the talk. We have about 11 minutes here. I have a contention and I have a case to make that we're the fastest database on the planet or the cloud. I think I showed you on my laptop, Windows, Linux, containers, desktop servers, and in our public cloud, whether it's Azure VM or Azure Database. We kind of had the benchmarks to prove it. If you don't think that these benchmarks matter, go look at the TPC-H specification a little bit. It's a little bit convoluted to read, but if you read just some of the early parts of the specification that are out there, it does something called power queries, where it runs a series of analytic queries consecutively, and it measures how fast can you do that. And then it has another algorithm to measure how fast can you do that in a concurrent workload, along with what they call refreshes, where you're going and loading data at the same time. So when you see these numbers like QPHH, it is a mathematical formula, but it really is measuring how powerful and fast can we run analytic query workloads. If you need a database warehouse, if you've not seen our fast track offerings, it is a partnership with hardware vendors to package a hardware system with SQL Server with a configuration for a data warehouse. And then if you really don't think Azure VM could meet a capacity need, have you seen the M series? 128 CPUs, 2 terabytes of RAM, 64 disks, and 160,000 IOPS. Whoa, that's actually not bad. That's a pretty powerful machine to run a SQL Server workload. And then finally, you might find this one interesting here. I did an informal poll inside Microsoft and with MVPs. I said, hey, what are the biggest SQL servers in the world you're working with? This was the average. The average around this poll of experts was 3 terabytes of RAM and 128 physical cores, not logical CPUs, but physical cores. That is not like the extreme, that's the average of what this poll came back. So if you don't think that SQL Server is running in large environments, you're mistaken. They are. Running in very large environments at very high speeds. This is just a comment I have about learning from the benchmarks. The benchmarks are run for a very specific reason. How fast can we run SQL Server? But you can learn from them. For example, TPCH, we always do partitioning in TPCH. We all use column store indexes. We manage our own statistics in the benchmarks. We actually try to minimize any automation that might be running to get maximum speed. You may not want to do that. You may want to use automated statistics because it's easier for you, right? But if you want maximum speed, you may decide to create and manage statistics on your own. Look at process affinity is an interesting one. So to get complete maximum performance from either Windows or Linux, we actually affinitize the nodes and the CPUs. I will tell you for a Windows system, that is not a requirement. The speed you're going to gain from that is not that significant on Windows, but on Linux it matters. And I have that actually in the performance guideline for Linux. This one's interesting. Turn off automation you don't need. There is this option called default trace out there that we've had for a long time for supportability reasons that creates a SQL trace by default in your system, not using Exadent, but SQL trace, and it records certain types of things. That's something that you may take a look at and decide, I don't care what's in that output, and so you may decide not to do that at all. And clients and networks matter. When we build these benchmarks, the tools to do the measurements are the clients. So of course we're going to maximize the network speed between clients and servers to ensure that delays in network processing are not causing lack in performance. Well, how does that help you? Well, you might run into that problem where you're having clients you're working with or in your account or your company where you're having performance problems and you're discounting the fact that the client application has to be a certain speed and the network has to be good to get the results to the client. Lenovo, I talked to the Lenovo team that does our benchmarking. They have certain recommendations that I'll let you take a look about, and they're not that complicated about how they actually set up the hardware from a disk perspective. Let's just talk briefly, a few minutes though, about what I showed you at the keynote. So HP has this concept they come up with called scalable persistent memory. If you've ever seen a technology called NVDIMM, an NVDIMM module, it's a new technology that is a memory module that acts like a disk, effectively. Now, what HP has done is something very clever. In order to save costs and to actually get scalable performance, they've built a technology, and I have the machine up front up here. That's not up on stage as it was there, but it's down right next to me. In that small unit right here, they have normal memory modules that are wired to actual NVMe SSD drives, normal drives, in a way that gives you technology like NVDIMM. But because they're normal memory, they're faster than NVDIMM modules. So that's why they call it scalable persistent memory, and it's why they've been able to achieve the sizes they have of 1 terabyte. It's also why it's a reduction in hardware costs, because it's cheaper than having all NVMe drives. And maybe you come up here afterwards, you want to see this. This thing's pretty thin. It is a ton of savings in rack space storage. That's what they call scalable persistent memory and called a diskless database. Because what I did at the demo in the keynote was I went directly after that drive, because it's just a drive to us, right, in SQL Server. We don't have any special code changes for it. Like I use drop clean buffers, right? And I went right after this disk in a matter of seconds, and I scanned like 6.5 billion rows. I'll show you again here in a second. One thing I want to mention, though, before I go on and show you the demos here, is the future of this. Because this persistent memory technology is memory, and it's all backed by power, okay, because of what we have in the system, think of a world where SQL Server could access that memory and bypass the software storage stack. What if we could actually access the SQL Server database files and not use the buffer pool anymore? Whoa. That would be pretty weird, wouldn't it? But that's the kind of thing we're heading towards. How can we take advantage of memory technology and the APIs and the SDKs they gave with us to literally access and copy data back and forth as it was memory, but it really is disk? That's really breakthrough. So look for us in the next releases of SQL and the future of what we're doing to start working closely with these vendors like HP to go start doing really breakthrough speeds for what is storage, but for SQL could actually be perceived as actual just memory. Okay, I have, by the way, in the appendix of this slide deck is some slides that HP gave me about the exact configuration of this machine. and more details about what this technology looks like. I've had a couple people come up to me and ask me how they could get access to talk to HP about this, and please come talk to me afterwards. I'll give you my card, and I can put you in touch with HP. So I have about 5 minutes. If we could switch over to 3 real quick. Am I here? Yeah, okay, great. So these were the queries I was showing you, and the reason why I told you in the keynote that it made sense to look at these is that this is kind of an analytic query. This is an aggregation of a sum, giving you what's called discounted revenue on your parts. And if you look here, notice there are specific parts they're going after in the syntax. Doesn't that smell like something you might see like in a reporting server or like a Power BI, where somebody went in and picked a certain visualization and then did like filters against it, right? That's typical. So when I kick this off right here, this is running against a database that's on that server. But here's what HP and we've done that's fairly clever to do these demos. We've hooked up to the actual device a separate rack of SSD drives that are not the persistent memory. So we're showing you the speed as it would be against these NVMe, which are pretty fast SSDs. I think there's like 10 of them in there that's striped together. And when we run this, if you see it here, oops. Yeah, it comes out. I guess I have a hard time with the mouse here, sorry. Here we go. About 15 seconds to do that. And then now this database, which is the exact same database we've done, it's the exact same one. We've called it a different name. This is going against the actual scalable persistent memory. Now this is all running on Linux. So for us, this is just a different mounted drive. That's all it is. So SQL Server doesn't know. We just created the database on a different drive. And then, you know, what I showed in the demo is, just to prove I'm not cheating, if you've not seen this command before, which is okay, this is called drop clean buffers. It's undocumented, but we use it for testing all the time. And it forces SQL Server to take any buffer pool page that's clean and not dirty and say, just discard it. So when I have to go after these pages on disk, I'm forced to read them from disk. I don't go to memory. This is not a warm cache scenario. So I'll go down here, and I'll use set stats I to run the query. And you'll see it's going to come back in a couple of seconds. And there we go, 2.6 seconds. That's crazy. That's running SQL Server queries, 1 terabyte database, directly against the drive as though it looked like it was warm cache. That's insane. Pretty cool technology from HP. Pretty excited to show you that. Can I flip back over to 2 again real quick, please? I'm sorry, the question is what? A what? Storage spaces direct? You know what? I think if you talk to HP further, they do have some ideas about using storage spaces direct for this. I think they showed that actually at Ignite to do that. So, okay, so this is back over to 2. I want to show you something just real quick here before we're done. This is a server in a lab I have in Redmond. And I want to show you this to kind of prove something that's interesting. I can't do a zoom in on this. This is running all 22 TPCH-like queries, the power query test, against a SQL Server 1 terabyte database on Windows, all 22 of them. So effectively, it took 3 minutes. Effectively, it is all warm cache. Everything's in cache at this point. But I went after probably 100 billion rows in 3 minutes consecutively. And because I'm using clustered column store indexes, that's the reason why I was told. If I run those against a row store index system, that takes about 10 times as long to run. Just to give you the idea of the power of clustered column store index technology, 22 queries over, you know, again, I'm scanning the same table against multiple times, right? But in totality, it's like 100 billion rows I'm going after. I counted it up, and I'm doing it in 3 minutes. That's pretty stinking cool. Again, another reason why analytic workloads, you should take a hard look at clustered column store indexes. Maybe you've heard enough of that now that you think I'm passionate about that. Okay, so I've got some resources. I don't have a lot of resources for you, but notice that the third resource, and I apologize in the community if I didn't pick yours, that's pretty, SQLServerPorts.com, I actually wish we'd grabbed that URL name. I like that. And it's actually pretty cool. I love our community. We have, you can give an ovation if you want here. Do we not have the best community in the world? We're the best community in the world. We do. If you don't go to websites like this, if you don't go to hashtag SQL help, you're missing out. Because there are some really amazing people that give up their own free time, not in their part of their job, their own free time to help all of you make this experience better. I hope I gave you enough feel today about that SQL Server 2017 is fast built in. It's faster than you think with the right settings and features and tuning. and that we're the fastest database on the planet. I think that we've got some pretty cool technology that could make a difference for you in your application. I'm going to stay here afterwards and take a few questions after you leave. Thank you for your time. Enjoy the rest of Past Summit. Thank you.